Welcome to the Algebra 1 Chapter 7 test review video explanation of the answer key. So again, please make sure that you have submitted your best attempt at the Chapter 7 review before going through this video and the answer key to make any changes. What we want to keep in mind in the first three problems to solve by graphing would be that we want all equations in slope-intercept form to make it easiest to graph. So y equals mx plus b, where the number attached to x in place of the m is your slope, and where the b at the end is your y-intercept. So let's look at number one, y equals 1/2 x plus 4. That's kind of this greenish line here. We know the y-intercept is a positive 4. So from 0, 0, go up 4. There's where we're crossing the y-axis. And from that point, follow our slope of 1/2. So up 1, right 2. Up 1, right 2. Draw in the green line. Then with the bottom equation, our slope's a -1 because it's a negative x. And then our y-intercept's a -2. So we start at a -2 and our slope is a -1. So down 1, right 1, down 1, right 1. Or you could go in reverse, up 1, left 1. And we'll see these two lines intersect at the point -4, 2. So that would give us one solution. In number 2, we want to rearrange both equations to get them into y equals mx plus b. So on the top, we would add x to both sides, so it'd be y equals x plus 3. On bottom, to get y alone, we'd have to add the 9 and then divide everything by 3, so y equals x plus 3. In this case, they're the same exact equation, meaning when we graph them, they are the same exact line, so we would have infinite solutions because they're the same line. And then in number 3, y equals 3x plus 4, and then 3x minus y equals 7. Top one is already in slope-intercept form, so that's our green line here. Start at the positive 4, go up 3, right 1, and that gives us our line. With the bottom equation, we would need to subtract 3x from each side, and then divide everything by a -1 to get rid of the negative in front of the y. So we would end up with y equals 3x minus 7. So for that line, crossing the y-axis at a -7, our slope is up 3, right 1, up 3, right 1. So because these are parallel lines, we would have no solution. So you could write over on the side here, no solution. They never intersect, so there's no solution to give. Then down here in the next 3, we're solving by substitution. So what you want to keep in mind is we need one of the variables alone to begin with so we know what to substitute. So in number 4, y equals x plus 2. So I can use this x plus 2 and put it into the other equation in place of y. So our other equation, 3x plus 2y equals 9, becomes 3x plus 2, and then in parentheses, times the quantity x plus 2 equals 9. Distribute the 2. So we have 3x plus 2x plus 4 equals 9. 3x plus 2x is 5x, so 5x plus 4 equals 9. Subtract the 4, and 5x equals 5. Divide by 5, and x equals 1. Now we can substitute that back into one of the original equations. So I'm putting it into y equals x plus 2. So y would equal 1 plus 2, meaning y equals 3. Then with number 5, we have x minus 4y equals a -4. So on that one, I could simply add 4y to each side to get x alone. So that top equation would be x equals 4y minus 4, and I will substitute the 4y minus 4 into the bottom equation in place of x. So that would become 3 multiplied by 4y minus 4 in parentheses, minus 12y equals -12. So distribute the 3, and we have 12y minus 12 minus 12y equals a negative 12. 12y minus 12y is 0. So what we're left with is negative 12 equals negative 12. Same thing as 0 equals 0, meaning we have infinitely many solutions, or all real numbers. Either answer would be fine. And then in 6, top equation 3x minus 4y equals 4, bottom x plus 2y equals 8. I want to solve the bottom for x by subtracting 2y. So x would equal a negative 2y plus 8. So we'll substitute that into the top equation in place of x. So we'd have 3, then in parentheses, the negative 2y plus 8, minus 4y equals 4. Distribute the 3, so we have a negative 6y plus 24, minus 4y equals 4. Combine the negative 6 and the negative 4y, negative 10y plus 24 equals 4. Subtract the 24, negative 10y equals negative 20. Divide by the negative 10, and y equals 2. Then substitute the y equals 2 back into one of the originals. So I put it in my rearranged bottom. So x would equal negative 2y plus 8. Putting the 2 in for y, so x equals negative 4 plus 8, meaning x equals 4. So over here in my ordered pair, it shouldn't be written as 2, 4. It should be written as 4, comma, 2, because x before y. So 4, comma, 2. Moving down to our 3 elimination problems. So remember, to eliminate, doesn't matter which variable you want to cancel, but you want one of the variables to have opposite values in front. So looking at 7, if we have 2x plus y equals 6 and 2x plus 3y equals 10, I decided to cancel out the x's by multiplying the top by negative 1. So that top equation became negative 2x minus y equals negative 6. Now when I add these two equations, the 2x and negative 2x cancel. 3y plus a negative y is 2y. 10 plus a negative 6 is 4. So 2y equals 4, divide by 2, and y equals 2. Then you can put that info back into either of the original equations to solve for x. So I put it into the original top, 2x plus y equals 6. So 2x plus 2 equals 6. Subtract the 2, and 2x equals 4. Divide by 2, and x equals 2. So our one solution would be the coordinate 2, comma 2. In 8, I need to multiply the top equation by a negative 3. So that becomes negative 3x minus 6y equals negative 24. Now I can add that to the original bottom equation, and what I see happens is both my x's and my y's cancel, leaving me with 0 on the left. On the right, 12 plus a negative 24 is a negative 12. So if both variables cancel, and the final equation is not true, 0 never equals negative 12, we would have no solution. If it was 0 equals 0, we would have infinite solutions. And then with 9, 3x plus 6, or 3x plus y equals negative 6, and negative x minus 2y equals negative 3, I multiplied the bottom by 3, so I could cancel my x's. So the bottom became negative 3x minus 6y equals negative 9. We're going to combine that with the top, 3x plus y equals negative 6, giving us a negative 5y equals negative 15. Divide by the negative 5, and y equals 3. Now put the 3 back into one of the original equations for y. So 3x plus y equals negative 6. 3x plus 3 equals negative 6. Subtract the 3, and 3x equals negative 9. Divide by 3, and x is a negative 3. So our one solution there would be a negative 3, comma 3. Then with 10, doesn't matter which variables you make student or adult tickets as long as you keep track of them. I made student tickets X, adult tickets Y. So what I know is student tickets were $5, adult tickets were $10, and they made $600. So all the dollars go together in one equation. So it'd be 5x plus 10y equals 600. Then we know they sold 85 total tickets. So x plus y, student tickets plus adult tickets, had to equal the 85 sold. And there are my two original equations. Now, I decided to use elimination to solve this, so I'm multiplying the bottom equation by -5 so I can cancel out my x's. So I end up with -5x minus 5y equals a -425. Add that to our original top equation, and we end up with 5y equals 175. Divide by 5, and y equals 35. Then I can put that back into one of the originals. I put it into x plus y equals 85. So x plus 35 equals 85. 85 minus 35 gives us x being 50. So we know there were 50 student tickets sold and 35 adult tickets sold. Now with 11 and 12, graphing inequality systems. So remember, our answer is going to be a shaded region. So the first thing we want to do is make sure we're in y equals mx plus b if possible, or if we just have the x and y's, we know there's special types of lines, either horizontal or vertical. So x is less than 3 would be a vertical dashed line going through 3. Y is greater than or equal to -2 would be a solid horizontal line through -2. Now to figure out the shading. It's top one, less than 3. So anything less than 3 would be to the left of this line. Greater than -2 would be anything above this line. So we're left of the green line, above the pink, giving us a shaded region in the upper left here. Then with number 12, top equation is already in slope-intercept form, same with the bottom, so I can just graph those lines. Top one is going to be dashed. We're crossing the y-intercept or y-axis at a +5, so we're going up 5. And then our slope is a -1/3, so down 1, right 3. Down 1, right 3. Drawing our dashed line. Bottom equation, crossing the y-axis at a -3, so we're starting at 0, -3, then following our slope up to right 1, up to right 1. Draw in your solid line. Now to figure out the shading, I could use the point 0, 0. So if I put 0, 0 into this top equation, I'd end up with 0 is less than 5. Yes, that's true. 0 is less than 5. So because it's true, we would shade towards 0, 0, which would be below this blue line to the left. Then with the pink line here on bottom, y is less than or equal to 2x minus 3. So if I put a 0 in for y and x, I'd end up with 0 is less than or equal to -3. 0 is not less than or equal to -3, so we would shade away from 0, 0 with the pink line, which means we'd be going to the right of that pink line. So we're to the right of the pink line, below the blue, which gives us this region down here in the bottom right. And then lastly, given the systems, we have to write the equations. So in 13, what I'm going to look at first is just the line itself. So I picked the dashed line to start with. My y-intercept is at -2, so I know it ends in a -2. My slope is up 1, right 1, up 1, right 1. So 1 over 1 would just be x. So my slope's a +1x, and it's -2. Then, to figure out the shading, they were above this line, meaning that y would be greater than x minus 2. It has to be greater than not greater than or equal to because it's a dashed line. Then with the pink line, or the pink one that I came up with here on bottom, we're looking at the bottom line here, crossing at a -4, so I know that equation ends in a -4. From that point, my next point on the line that I can tell is up 1, right 2. So my slope would be a positive 1/2 x. Then they shaded above this solid line, so y would be greater than or equal to 1/2 x minus 4. If I look at 14, I have two lines. We'll start with this one here, the vertical line. It's a vertical line at a +4, so I know it's x equals 4. Then they shaded left of that vertical line. Anything left of that 4 would be smaller numbers. So that means x is less than or equal to 4. Then for our slanted line here, crossing at a +4, so I know my equation ends in a +4, and my slope is down 1, right 1, down 1, right 1, down 1, right 1, and so on. So our slope is a -1x, which we just write as a -x. So we have a -x plus 4, and they shaded below this line, so that would be y is less than or equal to a -x plus 4.